Okay, so we have union of events and the multiplication rule. So union of events are all outcomes that are either in A or B or in both. Okay, so all the possible outcomes, basically. Okay, so that's going to look like this, probability of A or B. So with and, we did multiplication, and we had the and for joint. Now for union, we're doing the addition rule, so now we're adding. So the addition rule describes two formulas. And in those two formulas, it will depend on whether the events are mutually exclusive or not. Okay, so let's look at an example of this. For two mutually non-exclusive events, the formula will be like so, the probability of A plus the probability of B minus the probability of A and B. For two mutually exclusive events where they cannot happen at the same time, then you're just adding probability of A plus probability of B. So let's take a look at this example here. Okay, so non-exclusive means can happen at same time. And then mutually exclusive means cannot happen. Okay, so I have here in a group of 20 people, 15 like chocolate ice cream, 6 like vanilla, and 5 like both. Find the probability of chocolate or vanilla. Can you like chocolate and vanilla at the same time? Yeah, you can. So, all right, so we're going to do this. We're going to make A chocolate and V vanilla. So you have the probability of, we'll do C for chocolate plus the probability of V for vanilla minus the probability of C and V. So the probability of chocolate is 15 out of 20. Probability of vanilla, 6 out of 20. Yes. Oh, no, I said before, you might have missed it. I added a couple in as I was editing because I wanted more in there. So you want to just write it off to the side. And then the probability of chocolate and vanilla, 5 of them, like both. Okay, so you have common denominator, 15 plus 6 is 21, minus 5, 16. 16 out of 20 gives us 0.8. Okay, so that is one way to do this. You can actually visualize this with a Venn diagram, if you guys remember how to do those. So if this was my circle here, There's my other circle. Okay, and I made this chocolate and this vanilla the way you fill out the Venn diagram. You start in the middle with the 5 that like both. Okay, and this was like a survey with the check boxes, so you could check more than one. So 15 like chocolate, but we already counted 5 of them here, which means that 10 like chocolate only. 10 plus 5 would need to equal that 15. And then 5 plus 1 would need to equal that 6. And then you can just add all of those together. And that would give you 16 out of your total, which was 20. So you could visualize it with a Venn diagram as well. Okay, if you like them and remember how to put them together, but if not, then you would want to use this formula. Now this second formula here for two mutually exclusive events, you're just adding the two probabilities. I don't have an example on this. I think in the classwork we might have some examples when we get to that though. Yeah, we do. Let me see here. That's not the same classwork. I think let's take a look at this first example here. Do you guys have this in the practice? Because this is a good example of all of the probabilities that we have. And we'll skip 4.6 for the moment. But we're going to do that on Thursday. If I could find this, actually. Oh, it's sitting right here. Okay, so we have a random sample of 700 college students was asked if college athletes should be paid. The following table gives a two-way classification of the responses. Okay, so a two-way table again, like I said, you're going to see a lot of these. So we asked student athletes and student non-athletes. Should you be paid, yes or no? Okay, so they're classified in the two-way table here. Let's see the responses. Let's add them together. So should be paid, so this is yes. 240 plus 210 gives us 450. And then people who said no, 240 plus 10, 250. And then total student athletes, 240 plus 10, that's 250. Total non-student athletes, 450. And if I add the 250 plus 450, okay, that gives me the 700 total. Okay, so the first one, find the probability, okay, that the person, okay, one student is selected, is in favor of paying college athletes. Okay, so I'm selecting 1 out of 700, so 700 is my denominator. And what is the probability that they said yes? How many people said yes? 450. So the total number of people who said yes, 450 out of 700. Would be 0.643. Okay, find the probability that one person favors paying college athletes given that the student selected is a non-athlete. Okay, so start with the given. So this is a conditional probability. Given that the student selected is non-athlete, which means my denominator, how many total non-athletes did I survey? 450. So non-athlete, there was a total of 450. Okay, out of those 450, how many said yes? 210. So 210 out of 450, 0.467. All right, so then we have an and probability. So is an athlete and is in favor of paying student athletes. Now, when you have a two-way table, the nice thing about these is you actually don't have to do the multiplication of your probabilities. You can kind of just look at the table and do this. So is an athlete and is in favor. How many athletes said yes? So you're looking here, yeah, 240 student athletes said yes. That is your numerator out of everything. Okay, so out of both of these, 240 said yes. So 240 out of 700 gives us 0.343. Yes. This is an athlete that did say yes. So it's out of everyone, but let's say they're color coded, like, I don't know, white and red. The athletes are red. So it's a red card that has the yes on the card. And then is a non-athlete or is against paying non-athletes. So this one, okay, can you be a non-athlete and be against it at the same time? Yes. So this is that P of A plus P of B minus P of A and B. So here's what we're going to do. We got to find those probabilities. I'm going to do it up here so I can see my table. So probability of a non-athlete, over here. Okay, probability of a non-athlete. So that's 450 total non-athletes out of 750. Or sorry, 700. Okay. Against. Okay, total people that said no was 250. This total no here, 250 out of 700. And then non-athletes that are against, okay, non-athletes that are against was 240. That's this 240 here out of 700. Okay, so we're going to add these two, subtract this one. So 450, trying to put it here so I'm running out of room. Let me zoom out. Hold on. There we go. Okay, so we've got 450 out of 700 plus 250 out of 700 minus 240 out of 700. So $460. So 460 out of 700 will give us 0.657. So the nice thing about the two-way tables is you don't have to worry about memorizing too many formulas here. You can pick out the specifics on the table to help you with the problem, as long as you make sense of what the problem is actually asking you. So I'm going to stop there, and then for tomorrow in the virtual session, I'll finish this 4.6 here, and then we'll also finish the practice problems, and we'll start a little bit on chapter 5. Won't be too long of a session for tomorrow.